From here to the stars. I am your host, Stephen Euin Cobb. Join us in Luxembourg, December 2 to 5, 2024, for a visionary week of the human future in space among the stars at the IRG's first European Interstellar Symposium. Find out more at irg.space. Our guest today is Dr. Frank J. Tipler. Dr. Tipler is a mathematical physicist and cosmologist. Dr. Tipler is a mathematical physicist and cosmologist holding a joint appointment in the departments of mathematics and physics at Tulane University. He is the author of over 80 research papers, as well as several nonfiction books for a popular audience, such as The Physics of Immortality, Modern Cosmology, God and the Resurrection of the Dead, The Physics of Christianity, and with John D. Barrow, The Anthropic Cosmological Principle. Thank you, Doctor, for taking the time for this interview.
It's my pleasure to be here.
Since this show, From Here to the Stars, is produced by the IRG, the Interstellar Research Group, I would like to start with the lecture you gave at the IRG's 8th Interstellar Symposium earlier this year in Montreal, Quebec. Its title was The Ultimate Rocket, the Ultimate Energy Source, and Their Use in the Ultimate Future. If you would, describe this piece, perhaps starting with the ultimate energy source.
The ultimate energy source is the complete conversion of matter into energy. Now, let's consider our approximation today of that. First, we use nuclear fission in our bombs and in our reactors, but only a small fraction of the total mass of the uranium is converted into energy. A huge amount compared to chemical reactions, but still a negligible fraction. The same is true for thermonuclear fusion, which is the power source, of course, of our sun. What's happening inside the sun is you're converting hydrogen into helium. But if you compare the mass of the original hydrogen atoms to the final helium atom, the term we physicists are taught to remember is 007. 0.7% of the mass of the original hydrogen atoms are converted into energy. Now, that is a tiny percentage. That is less than 1%. The best you can do is 100%. And that will be the ultimate energy source. Now, an example of how it would work is take a proton, take an electron, that's a hydrogen atom put together, and combine them and get out nothing but energy. That would be the perfect energy source. There's a little problem with that. It violates two laws of physics. Baryon number conservation. A baryon is a heavy particle like a neutron or a proton. That's the P in the reaction. And it also violates lepton number. A lepton is a light particle. The typical example, the example in this particular reaction is the electron. So you're violating two laws of physics in order to get a perfect conversion into energy. However, the laws of physics don't start there. We know there has to be, we cosmologists know there has to be some process in the extreme early universe that generated the matter which we see. Somehow it generated matter rather than antimatter. There's a negligible amount of antimatter out there, which we can see, because if there was an antimatter galaxy, and here is a galaxy, then there would be a boundary between the two where matter would interact with antimatter and convert into energy. Now, if electron combines with a positron, the anti-electron, it produces two gamma rays, each of energy 517 keV. We've looked for that all over the sky. We've not seen that radiation anywhere. Thus, as far as we can tell, it's matter all the way. No matter, antimatter out there of any significance. We can create antimatter. We do, for example, in our accelerators by slamming two protons together. So much energy is in the two protons when they slam together that there is more than enough energy to create a proton-antiproton pair. That's how we can create matter, antimatter. But some process must have occurred in the early universe that created matter without also creating antimatter, which we can't do. Now, there's only a debate amongst we cosmologists is what exactly is the process. Now, in my talk, I point out that the standard model of particle physics, which describes all forces and all materials except for gravity, and we've had the theory now for about 50 years. We've thrown huge numbers of experiments at it, and the standard model has always passed with flying colors. So the standard model, I claim, ought to be able to explain how matter was created in the very early universe. And in my talk, I described how that would work. And if you reverse the process, proton plus electron would work, because in the standard model process, it's not B separately and L, that is baryon number, and lepton number that are conserved, but rather B, baryon number, and L, lepton number, subtracted from each other. B minus L has to be conserved in a reaction. So, in the standard model process, B minus L to start with for the proton and electron combination, that's 1 for the baryon, minus 1 for the lepton, that gives you 0. So there is 0 lepton minus baryon number initially there. So if you have a proton and electron coming together in the standard model process, you can get out, say, 2 gamma rays, pure energy, and you don't have to go through this rigmarole of creating antimatter. Now, that's how I describe the process. I described the process in my lecture of how to produce, how matter was produced in the early universe, and pointed out that any process we know goes one way, somebody can figure out a way to make it go the other way. Now, all I described in my talk was how to make it go one way. And I said, I haven't got a clue how to make it go the other way. I have to leave some problems for you guys. So I'm describing how matter was generated. You go out there and figure out how to reverse the process. But we all know there has to be some way to do it. Now, that is the ultimate energy source. You could also use it for the ultimate rocket, because if you create by just annihilating matter and getting a beam of photons out the other end of your rocket, that is the ideal rocket, because the ideal rocket must satisfy the first condition. It has to have a maximum specific impulse. Now, the specific impulse is basically the exhaust velocity of your rocket, of the material going out the end of your rocket, divided by the acceleration due to gravity. Now, that's 30 million for anything moving at light speed, which of course photons do. But we haven't come close to approaching that. The V2 rocket has a specific impulse of around 200. The current rockets, SpaceX, for example, may reach 400. So we've gone up by a factor of 2 since the Second World War and the present, 70 years? But how far do we have to go? The specific impulse, the ultimate specific impulse, is 30 million. So we've got to reach 30 million. We're just at 400. In the last 70 years, 200 to 400. We have quite a way to go. So this is the process where you actually get maximum possible specific impulse. So you can also have the ultimate rocket here too. But there is a caveat. I want something more than just a specific impulse of the maximum, which is light speed. I also want to have the exhaust velocity being also not affecting the environment. If I have a gamma ray beam coming out my rocket engine, it's going to vaporize the takeoff pad. Remember what happened to Starship? He had this beautiful, Elon Musk had this beautiful engine. It was really powerful, so powerful it wrecked the takeoff pad. That's not an ideal rocket. What you would want is have gigantic force going down, forcing the rocket up. And from the point of view of a person, not just a rocket pad, but a person standing underneath, he doesn't see anything at all. That's the ideal rocket. So what I propose is, rather than having a proton combined with an electron and generating two gamma rays, two photons, let's have it generating a neutrino antineutrino pair. Now that still gives you B minus L of 0, so that's possible, but neutrinos interact very little with normal matter. To stop a neutrino beam, well, let's suppose we have a neutrino beam and we're trying to attenuate it with lead. How much lead would you have to have in order to knock out half of the neutrinos? You need a lead shield of about a light year thick. Bottom line, neutrinos hardly interact at all with matter. So you could have a powerful neutrino beam coming out the back end of your rocket. A guy could be standing in the exhaust of that rocket and feel nothing. The rocket would just take off above him. Now, the model which I gave in the talk, I showed an excerpt from Back to the Future. Remember when the Doc returns from the future? He has first a matter conversion element. He dumps in garbage and he generates energy. Now, that's the perfect energy source, but that's exactly what I have described. If you can have a proton plus an electron combining, basically you can use garbage as your energy source. I love it. That's the perfect energy source. Any sort of matter, garbage works. But also when he took off, he used a rocket, but you notice it did not affect the pavement at all. That's a neutrino beam. So what you're seeing at the very end of Back to the Future is the ideal rocket and also the ideal energy source. Now, I've described the laws of physics and what they will allow in principle for this rocket to be constructed. As I've said, all I can do, I'm a theoretical physicist, all I can do is describe what is actually laws of physics actually permit. Then I gave also in my talk, I got some money from Peter Thiel, the IT billionaire. He's famous for saying, I wanted a flying car, think Back to the Future, but I got 140 characters. So Peter Thiel is interested in building a flying car. So if the process, the standard model process, is the one that actually worked in the early universe to generate matter, the process, if it reverses, gives us the flying car. So Peter Thiel, being interested in actually building a real flying car, gave me some money to build an experimental apparatus, which I used to see if, in fact, the standard model process was the one that worked. And so far, the data is looking good. I presented the data at the meeting, and it looks like, indeed, it's the standard model process that generated the matter we see in the universe. Then I went on to discuss the ultimate future.
Okay. Did that cover the paper completely?
Just the ultimate future. I've got infinitely far to go into the future. This just covers the next few thousand years.
Oh, okay. The avalanche of new data coming in from the James Webb Space Telescope is creating quite a buzz in cosmological circles. Is any of it affecting your work? And if so, in what way?
Well, it's confirming my work, because I mentioned in my paper describing this that one of the problems which is originating from the Webb Space Telescope is that galaxies are forming earlier than expected. Now, the two outstanding problems in cosmology are: what is the dark matter? We've not seen it except from its gravitational effect. And second, what is the dark energy? The dark energy combined with the dark matter is 95% of the material, whatever it is, in the universe. Now, isn't it interesting? We cosmologists do not have a clue what 95% of the material in the universe actually is. Do we really know something about cosmology? Now, I ask myself, the standard model of particle physics purports to describe all possible forces and material except for gravity. Now, if the standard model does not describe dark energy and dark matter, well, it would not describe all the matter and energy in the universe, right? So we ask the question, can the Standard Model actually explain what the dark matter is and what the dark energy is? And the answer is yes, it does. One of the things about the Standard Model is the Higgs field. You may have heard about the discovery of the Higgs boson in 2012. Now, that was just the icing on the cake, so to speak, of the Standard Model. The Higgs boson itself has a more important role to play. It gives mass to all of the particles in the universe. The entire universe, in other words, according to the Standard Model, is permeated with a universal Higgs field, and the interaction of all the regular particles, which by themselves have zero mass and therefore should move at light speed, actually, when they interact with the Higgs field, they get mass, and therefore they don't move at light speed. Now, of course, the proton and the neutron slightly different. Most of their mass, not all of it, but most of their mass comes from the binding energy of the quarks making up these particles. But all of the mass of the electrons, for example, comes from the Higgs field. Now, I like to say that the Higgs field is the most important particle in the Standard Model, because the extended Standard Model, that is the Standard Model with neutrinos having non-zero mass, which they do have non-zero mass, has 25 parameters, which the Standard Model doesn't directly say, at least apparently, exactly what they are. But of these 25 parameters, 23 refer to the Higgs field. So that gives you an idea of the importance of the Higgs field. It's really important. Now, if the baryogenesis mechanism, baryogenesis is the technical term we cosmologists use for the process that creates matter rather than antimatter in the early universe, something created the baryons, is created by the Standard Model process, then in the very beginning of time, the Higgs field was initially zero in magnitude. Now, what happened as the universe expands is the Higgs field fell off its peak and went down to its minimum and is oscillating right now around its minimum. Now, this interesting fact, the oscillation energy, remember the Higgs field has an oscillation energy. You can compute what would happen to that oscillating energy if it were in an expanding universe, which it is. The Higgs field is in an expanding universe because the universe is permeated with the Higgs field. The universe is expanding. It was discovered 40 years ago. I didn't discover it. A great physicist, Mike Turner at the University of Chicago, discovered this, that to first order, the Higgs field will act as if it's zero pressure matter, which interacts only gravitationally and weakly with other matter. In other words, an oscillating Higgs field has exactly the process of the properties of dark matter. So the Standard Model says, aha, that's what it should be, an oscillating Higgs field. Now, the interesting thing, and this is as far as Turner took it, that just gives you the energy of the Higgs field to first order. But there are other terms, according to the Standard Model, which have to be there. When you take into account the other terms, it turns out that it's not exactly expanding according to zero pressure, but rather it has a slight, get this, negative pressure, very slight. But the negative pressure tends to pull things together. Rather, the pressure pushes things apart. That's regular positive pressure. You explode a bomb, it's the positive pressure that blasts you off your feet. Negative pressure, if the bomb had negative pressure, you wouldn't be blasted away from the bomb, you would be pulled toward the bomb. That means a negative pressure tends to pull things together more than expected. Now, if in fact the Standard Model dark matter is what you think what it has to be, namely the vibration of the Higgs field, then in the very early universe, there would be some extra gravitational effect causing galaxies to form earlier than you would expect from the standard cosmology, what's called the lambda CDM, lambda cold dark matter. Cold dark matter means zero pressure. But with a negative pressure, they would form earlier. So the bottom line answer to your question is that the Webb Space Telescope is indicating that my theory is right, even more right than I initially expected before the Webb Space Telescope. But there's another plus. This extra energy explains another cosmological problem called the Hubble tension. The Hubble tension is that you can measure the Hubble constant today. That's one way of getting it. Also, you can measure the Hubble constant very early in the universe using the microwave background radiation observations, and that gives you a value for the Hubble constant way back then. Then, under the assumption that there's nothing around but the dark energy, which looks like a cosmological constant, lambda, and zero pressure dark matter, that gives you a predicted Hubble constant today. Here's the Hubble tension. These two numbers differ by 5 sigma. They are drastically in disagreement with each other. But when you take into account the very slight negative pressure, which the standard model explanation of dark energy predicts, then the Hubble tension is exactly explained. So all these observations are confirming the theory of how the matter was actually generated. And also it tells us, it confirms even more the mechanism which we will eventually use, our descendants will use. You and I are too old, alas, to see this because it requires more technology than I think I will see developed in my lifetime. But I know that sometime in the future, somebody will figure out how to reverse the process and convert matter back into the original energy. So they will possess the ultimate energy source and the ultimate rocket.
As far back as 1974, you put forth a paper on the Tipler cylinder, also known as the Tipler time machine. Talk about that a little bit, if you would.
Well, I proposed, it was the first paper 50 years ago, next year. My goodness, it's been that long. I proposed that by rotating a cylinder, you could generate a time machine. Now, the way that a rotating cylinder would work is that light cones, which define the direction of future, you have to move inside your forward light cone, we say. But what happens when you have a rotating cylinder? Gravitational fields affect the direction of your light cone. For example, if there were a black hole right here, then the gravitational field of the black hole would pull the light cone this way. As I move toward the surface of the black hole, the light cone moves further and further over until when you touch the surface of the black hole, the event horizon, then this area of the light cone is pointing straight up, i.e., a light ray launched outward precisely at the location of the surface of the black hole would stay on the surface of the black hole forever. So gravity affects the direction of the light cones, i.e., the direction of the future locally. Now, rotation of a powerful gravitational body not only pulls it toward, but twists it around. So if you have a rotation this way, the light cones are tipped over in the direction of the rotation. Rotate it faster, a really powerful gravitating body will tip it over until finally the future direction is also in the past direction at infinity. So as you go around the hole, this rotating cylinder, you go backwards and backwards in time. So you can return to your starting point far away from the cylinder before you left. This is true time travel. Or, for example, you could go really far, however far the rotating cylinder has existed. You could go back into that time. If it had been around for 1 billion years, you could go 1 billion years into Earth's past, and you could watch oval evolution proceed. Unfortunately, 2 years later, in my PhD thesis, I was able to prove that, I have to cry here, rotating cylinders won't work. Because what happens, what I was trying to do is imagine you actually create one. In the process of creating it, I was able to prove mathematically that you would create a singularity in space-time at the instant of creation. And a singularity inside of space-time is not allowed. It violates a fundamental law called unitarity. Now, this was a great discovery of Stephen Hawking, which he made about the same time. About 73, I think he published his paper on evaporating black holes. He showed that were a black hole to completely evaporate, it would end in a singularity. That singularity would annihilate information, and that's called, the annihilation of information is called the violation of unitarity. Now, it's a fundamental law of quantum physics that unitarity holds. It follows the law of unitarity from the law of conservation of energy. You can prove if energy is conserved, then unitarity has to be good. Conversely, if unitarity is violated, energy conservation also has to be violated. Now, you might think, well, we've not made a really precise measurement of conservation of energy. Maybe that's just a teeny bit of violation of conservation of energy in a unitarity violating process. Unfortunately, not true. Leonard Susskind of Stanford University was able to prove in the late 70s that if you had a unitarity violating process, if it coupled to electromagnetism, the energy non-conservation would amplify so that there would be no limit to the amount of energy being generated out of nothing. Now, Susskind got a little nervous at this. Rather than infinity, he said, well, let's just cut it off at the Planck energy. But the Planck energy is not a small energy. It's actually the energy in a half a ton of TNT. So any little process that we had in a laboratory that violated unitarity, right then, instantly, a half a ton of TNT would go off in the laboratory. I think we can agree that does not happen. Now, it's also proposed by people like Roger Penrose that when we make an observation, the observation process violates unitarity. Now, I've asked Roger, do you really believe that every time you make an observation with your eyes, a half a ton TNT goes off in your brain? Talk about heads exploding, we would see it. We don't see it, obviously. And Roger has never gotten back to me on that one. So I think we can conclude that unitarity is not violated. Now, I'm going to let people rest on that, and I'm going to lead up with that important observation. Unitarity is good in discussing the ultimate future. But any other questions first?
That was Dr. Frank J. Tipler. This has been From Here to the Stars, a video series produced by the Interstellar Research Group. The IRG is a nonprofit organization dedicated to thoroughly exploring the science and engineering that can eventually open up the reality of interstellar travel. Join us in Luxembourg, December 2 to 5, 2024, for a visionary week of the human future in space among the stars at the IRG's first European Interstellar Symposium. Find out more at irg.space. I have been your host, Stephen Euin Cobb. If you enjoyed this video, please hit the like button, and you can subscribe to our channel for other such videos. On behalf of all of us here at the Interstellar Research Group, I thank you.